So in general, let's see, I'm just going to do, so now we're going to do this. We're going to do docker build -p dash. Same thing. So all this is going to do is this is going to use the previous container built, and then it's going to run. It's going to run this. It's basically just going to run Keras, the pip install stuff on that same container. That's all it's going to do. Yep.
Better than previously. Yeah. If anybody doesn't have a problem with the weekend, just improve the difference.
Probably just need to mount the around.
Better than previous.
Start with that. Yeah, try that. Because Docker actually needs to mount. The problem is Docker actually needs to mount it. It needs to be able to mount it receive right now. No, just move it over. Just move it over. Yeah, so you can specify vertically. So you can say equals equal to whatever. That's just normal. That's just normal official Python. Pip install. You should know that. I'm not going to go. Pip install equals equal to whatever. Then you just Google that. That's a general. That's a general thing. Anyone over here have problems? Yeah. Okay. Okay, cool. Okay. So after you run that, what's going to happen? So what we're going to do next is we're going to type docker compose up. So docker compose up, what it's going to do is it's going to use the locally built images and it's going to download some new ones. And what it'll do is it'll actually start a server with everything pre-installed. So if you remember that docker compose.yml I was showing you earlier, that's going to start a whole cluster and everything for you. So go ahead and type that, and I'll start going through the docker compose.yml again. So So again, it's just docker-compose up. And it should start downloading a bunch of stuff. Yep. Yeah, it should start. It should say like pulling blah blah blah, pulling blah blah blah, and then I'll start downloading a bunch of stuff. Yep. Yep. Yeah, that's fine. Okay, so yeah, some of you will be building for a while. Some of you will be doing the next step where it starts downloading like a few more images. After that, we're done. This is the last time. I swear. Okay.
You already used to it, right?
Not sure what it was doing, but there you go. Cool. Okay, okay, cool. So now what I'll do is I'll go through what does it look like when it's up? What's it doing? So I think you skipped the second Docker build. I'm not sure. Hold on. I just ran build again. Okay. Okay, so now let me show you. Yeah. Okay. Okay. Yep. This is something specific to Docker. Docker machine, I know. I'm not sure about Docker machine. Yeah, don't worry about it. Yeah. I'm so sorry, I'm not sure. I know like Docker machine, I know is going to be yeah, well, all the stuff is already prepared. It's already yeah, take this kind of yeah. Yeah, well, I'll we're gonna, I'm posting the links as I go down. Yeah. Okay, so when everything's up and running, what are we doing? So, okay, so after it's up, this is the output from Docker Compose. So this is with everything running. So you'll notice it's downloading. When we run, we're going to end up running Keras and a bunch of other stuff. And what happens is you have the container name. So you have the container name next to the output. And so whenever you do something, the output will appear here. So you'll see Grafana, Jupyter, you'll see a bunch of stuff, right? So container name and then log message. So what's happening here exactly? Well, turns out, so for example, this right here, this is running in Docker. So you'll notice if I just do localhost 8888, this is actually running in the container itself. So somehow on port 8888, somehow everything's up and running. I have a whole cluster. So all it is one command, Docker Compose up, boom, everything's running. That's all you got to do. And you have a whole, actually you have a whole system for model serving, notebooks, and dashboards. All in one go with time series metrics and everything. One command. So all this stuff that was easy to set up are some of the extra components like production monitoring, all that other stuff. You get all that and it's all open source. And you set it up with one command. So the notebooks in there's a few notebooks in there. What I'll do is I'm going to grab the Python script creation just to show you what it's running. And so what's going to happen is we're going to end up running a Python script on the model server itself. So what are we running? This is the actual script we're running. So what we're going to do, we're going to use pipelines to actually run a server. This is actually how you start a server. So you don't have to know anything about this. This is already all taken care of for you. Just know that this is just more of a sample for you to understand. So this is kind of the Python SDK. This is already all built into the container. And what it does is it creates a configuration and then it outputs a JSON file. Right? Like, so this is all inside the server. So this is how we're going to run the Python code. So we specify some inputs. In this case, we're going to specify an image path. That image path will be a path to an image that's local on the machine, and we're going to tell it, find this image on your machine, and output the label and the probability. So not complicated, this all does, right? It's just a configuration, kind of like how you would have like, if you've ever done TF serving or any of these, or Kubernetes or any of these other things, generally sometimes you have to have a YAML file to set up your server. This is no different, right? Like, so you pre-configure like some form of a configuration that says run this script at this path, right? So when I mentioned earlier, right, you have to have a model file, right? Like, so somehow you have to configure it. The model file is here, the Python script is here, right? The inputs and the outputs are this, right? You're basically describing what you want it to do, right? Like, so I'd say most model serving platforms have this. So another one would be Seldon, for example. TF serving, there's a lot of different ones you can use, right? And they all basically require you to do the same thing. Instead of you writing instead of writing a Flash server yourself and understanding like how to do the vectorization and preprocessing and all this other stuff, instead you as the developer just describe what you want to do and that's it, right? Like, so that's the point of these platforms existing. TF serving is similar, so. And actually Google's like TFX now, as they're calling it, TensorFlow Extended, that does a lot of other stuff. Same thing, you configure it, and it'll do all those things that were hard that I was saying earlier, like automatically batching the number of images you send it, and all these other kinds of things like that, right? Anything that would cause your server to go out of memory or things like that. Like, you don't know much about software engineering, but you don't want your server to blow up. Model servers, that's what these kinds of model servers are for, because they generally do this kind of thing for you. And instead of me telling you, write code that does X, Y, Z, I say change this number to 1 instead of 5, right? Like, just simpler things like that, right? So that's what's all pre-configured in here, essentially. right? Like, so what we're going to do is we're going to run a script with this Python path. So so if you've ever dealt with, you've all dealt with Python paths, I assume, correct? At some point, you have to set like so generally you have to set a Python path. So sometimes it's pre-configured. If you ever do import sys, print sys.path, this is what that is. Right? Like, so if you ever want to use, so when I want to hook up like our model server to a custom Anaconda distribution, generally what I'll do is, it's actually pretty simple to hook up. All I do is I say, give me the system.path. Done. That's all I gotta do, right? So that'll give me the system.path. I pass that in, and it ends up in this file. And then the server can like do the number of workers, the port, etc. So you remember what I said earlier, you have to specify a port, right? Like, so you specify a port, the Python path, and you have a REST API that runs Python code. That's all you gotta do, right? Like, so it all happens via REST API. And so I won't explain everything about how it works. Just remember that simple thing I was talking about where you have a client, which I'll show you in a minute, that connects to a server. That server returns a result. Right? Like, so all you need to know is that you can specify a path to a Python script, and it will just run it. So you don't have to worry about multi-threading and some of this other stuff. So where does that come in? Like, why do you care about that? Well, if you want to take something fairly off the shelf, so say a Keras script, for example, right? What's involved there? Let me see. I want to pull up like an exec.py. So you'll see here, you'll see on GitHub, this is all on GitHub in that same folder, and Docker Compose and everything's here. And in here, there's a few things. One of these things is input data. So input data contains everything we need to run the server. The Python script we want to execute, an example image, you just put it here and it actually mounts it to the container for you. That all happens transparently. In the Docker Compose.yml, there's something called a volume, and you specify // input data mount, so colon, and then the absolute path to the location where you want it to mount. This will appear inside the container. You got that for free with the Docker Compose file. So that all just appeared for you right there. So what you do then is we're going to execute this Python script. So what's going on in there? Oh. Here we go. Okay, so now we're finally in comfortable land now. No more networking stuff. Okay, so this is just straight Keras, right? Here's what we're doing. So what we do is we're taking in a model. Well, so what happens is we send an image path over using JSON to the server, and then what happens is actually kind of cool. We actually do code injection. We actually have our own Python distribution and everything built in. That's why you specify a Python path, because we have our own C Python distribution built in. It's all pre-installed. And if you want to do something custom, you just give us a path, and then we're good to go. And then we can execute scripts like this. So what we're doing is we're in this case, this is just an example image. What we're doing is we're injecting this variable. What it does is it puts the variable declarations here, like image path, and then it basically runs Keras for you. So what are we doing here? Well, in Keras, it turns out this is something a lot of people don't realize. When you're dealing with Keras from real multiple threads, you have to do this. You actually have to give Keras a session. You have to create a new session for each thread. So this is something you only run into if you're doing multi-thread. So if you run a real server, you create a session, you set it, you set up ResNet, you load the image. See, this is your pre-processing step. You pre-process the input, you do predict, right? And then what are you doing? You call decode. So this is just using the Keras model zoo, by the way. So all you're doing is you call decode, and then what do? We give back the probability and the label. We give that back as JSON, and then the server prints that out. So that's all run remotely on the server. So you just send it an image path. This is hosted remotely, and then so you can directly deploy Python scripts as is. You set up you set up an Anaconda distribution, and then it runs this Python script remotely for you. So let's see what that looks like in practice. So I think, let's see. So I have the, so here's how that works. You have a client. So this is the, this is an SDK. The SDK, in this case, again, as I mentioned, it's client server. So you have a client, you set like the endpoint, and then you set like what you want your return types to be. So as I mentioned earlier, right, like there's all these different ways, there's these different kinds of data, like text. So generally we're going to return JSON in some form, right? Like that's generally most of the time you're going to return some form of plain JSON output. Sometimes though you can return things like something I'll briefly show, something called Apache Arrow. Apache, if you ever want to use, if you ever want to directly return a pandas data frame via REST APIs, we do that automatically. So you can actually call predict and you get back a data frame. That happens transparently. That's all using something called Apache Arrow. But for this, we're just going to use JSON. So what are we doing here? You specify, so when you think of input names and output names, this is just like TensorFlow. So if you want to run TensorFlow or PyTorch, generally one thing you have to do is you have to specify the input names and the output names. So this allows you to do some crazy stuff, like one Python script per input name, for example. So if you have pre-processing per, so say you have an image input and a text input, you can run different Python scripts for different parts of the, for each name. There's a lot of stuff you can do. We have a timeout. So another thing you're missing is when you have when you're doing something over a remote network, that remote network generally can do something called timeout sometimes. So you know, if you ever go to a web page, that web page sometimes will just say, oh, the connection timed out. That's because when you have like a long running process and you're doing transactions, you're waiting for a response. But at some point you don't know whether it's broken or not. So you specify a timeout. So in this case, I'm specifying 300 seconds or 5 minutes. Because the reason I do that is because when I invoke the script, Keras Applications actually has to download the model first, if it doesn't already exist. So you give it a timeout, and then it'll transparently just download the Keras model and just run it. After you warm it up, then you're good to go. Then you don't need to worry about that anymore, right? And then what you do is you specify your input type and your output type. So what are these for? Well, we have an input type of JSON. So we're saying, I'm going to send you JSON. I expect JSON back. But one thing you can do is we have endpoint output type, like raw or what have you, right? Like so, turns out if you want to return, say, a NumPy array directly, a binary NumPy array, we can do that. So we'll directly return a binary NumPy array, and then you can just call numpy.load directly in memory, right from the output of client.predict. So you can do some fancy stuff. I'm not going to try to show all that today, just because you end up getting in some rabbit holes. The basic idea, though, is generally you want some form of output you can use, whether that be a NumPy array in your experiments or something else, right? So you return the output. You specify a URL, as I mentioned earlier. In this case, we're specifying HTTP, and then pipeline. Pipeline is a host name. So Docker Compose automatically maps a host name for you. You don't have to worry about it. So you can use nice pre-configured things. If you're in the container, you can get nice pre-configured names. So it'll say, contact the model server on this port using this image path. So your image path ends up being USR share input data. So remember when I mentioned the volumes thing earlier? So I'm actually taking something from the Windows container, or from the host machine, and I'm saying the input data directory on my machine should be mounted into the container. And then what will happen is the container will then see USR share input data mounted. So if you change it locally in your machine, it'll change it in the container automatically. So it's literally mounted into the container itself. So you do USR share input data, you specify predict, and you get back a result. So this is for what it's worth. This is a this is pretty self-contained. You'll have to do this. You'll have to do this in some form, no matter what libraries you use. Actually, you'll have to specify like the URL. You'll have to post-process the output somehow. Like take a NumPy. So one of the typical examples is like a softmax, right? You need to take that softmax matrix and then you need to parse out the result. So like, calculate the max row for each one, the max label for each one, and then somehow you need to print out this label, right? Like somehow you need the nice output that you can use in your application, right? Otherwise you're just returning a NumPy array. Sometimes that's what people want, but it varies depending on your application, right? So in general, right, no matter what libraries you're using, whether you write this yourself using Flask or what have you, depending on who you deploy, right, you're going to need to do the same song and dance. You're going to need to specify a host name. You're going to need to start a server, run a client. You're somehow going to need to do all this yourself, right? Does that make sense? Again, you send JSON, you get back you get back out JSON results. You run client.predict, and that runs a Python script. That's all it's doing. And then from there, what I just described to you was the plumbing. Like, what are the problems you run into? What do you need to know? Like, how do I connect to a server? How do I know how do I set up a server? Those are all the things that I just described earlier as prerequisites, right? So if you think about, if you go back and you just read the things that I was telling you earlier, right? Like host names, IP addresses, domain names, whatever. This will all start to make sense. So, questions?
Does that take care automatically of, like, if you're looking at servers that are backing?
Load balancing. So you would actually, that's a good point. You actually generally you have to set it up yourself. So that's generally where you're going to use Kubernetes or something of that nature.
It's not taking care of some, like, I don't know, because of frame.
Oh, so pipelines, yeah. So pipelines is for individual servers, and then that's open source, and then orchestration, and then we generally sell orchestration, where you can use Kubernetes. So like we have if you're into Kubernetes, we have a Helm chart and everything. That's all pre-installed. But generally, what we found in practice is that people have way too many opinions about how a cluster should be set up. So we generally try to integrate instead. So if you look at like what pipelines has available, just give you an example. So what are all the different ways people package software? So that's another part of this. So with pipelines, you can do Docker, you can mix and match like CPU or GPU, you can do EXEs. We don't have DMGs yet, but you can do like RPM, Uber jars. There's a lot of different ways you can essentially set up the server. So it really depends on how you want to package it. But in general, like we don't have opinions. We just let people pick. Docker is generally the most off-the-shelf thing people do. So they just do Docker, and then I'm just kind of showing like how would you run a basic web service. Some people use Docker Compose. Other times people use a Google Container Registry or something similar like that. But what we have here is like the basics. Like you set up one image, and then you're good to go. Most people don't need. Most people here probably have Opera projects and don't want to run. They don't need to run a load balancer or anything. But if you want to run a load balancer, then generally that's going to be outside the service workshop, and distributed microservices would be a whole other thing. So I could show like how to orchestrate it as well. So. Okay, we'll do troubleshooting in a bit.
I'm familiar with the Azure machine learning pipeline.
Mm-hmm.
Would it be correct to say that these pipelines are also similar to what these guys have built for?
Yeah. Yeah. So basically, what we do, the general idea behind the framework is think of it like Spark, right? Spark has their pipelines. Everybody has sklearn also has pipelines.
Yeah.
So the general idea is we define pipeline steps, and then you can run like a Keras pipeline step or a TensorFlow pipeline step, and then those run native in Java and C++. Or you can run a Python pipeline step and run a Python script. So there's a bunch of different ways you can set it up. But basically, you describe what you want to do as a series of steps.
And I guess one of the other things that's good about pipelines is that by doing model learning, you have some data preparation techniques that you can modularize them in steps and then reuse them in your prediction.
Bingo, exactly. That's the main idea, yes. So you take your cells and you copy and paste it into a Python script and say that's a step. I hope you don't actually do that, but it allows you to. That's what some people will do.
Yeah.
Sometimes that's the easiest way to get started.
So I guess in real production, this is what is going to happen. You're going to take your data, build a notebook, see what it says, and then build steps out of it, embed it.
Yep, exactly. That is the actual workflow. Yes. That's why we made. That's actually why this is a run Python script example, because I assume people are going to copy and paste Python code cells into a script and say, here's the path. That's what I've seen in practice. That's actually, even though it's not the best way to do it, that's what most people want to do. They just want to run a Python script.
That's the reason we are is because people generally work on static data.
Right.
They're not working on something on live data or production data.
Exactly.
They have a CSV. They want to build a model and do a prediction on that.
Yep, exactly. Well, yeah, that's kind of who this is. That's kind of like who the open source is targeted at. It's like, I want to run a model. I want to run it on multiple threads, and I want flexibility and like the number of workers and like basic things like that without worrying about how to set that up myself. This is what that's for.
One question, like to manage that versioning, do you manage that outside of this framework?
Mean what?
Versioning.
Versioning is also, this is just serving. Yeah, so versioning I also consider orchestration. Again, people have, you can use, there's a lot of open source tools for that. So like, if you want to do versioning, for example, so some people use like ModelDB. This is an open source project out of Yale. So if you want to do versioning, you can use this. This takes care of like all your metadata and everything.
Wondering, was there a versioning you want to have the pre-processing step where you have that code and data?
That's the thing. Generally we have our own orchestration system for JSON file and all that other fun stuff.
Is this similar to
MLflow? Yeah, MLflow is another way of doing it. But MLflow generally, or no, I forget. Does MLflow require Spark? I don't think. Yeah, but MLflow has a component for that. So this is another one. See, they have the whole lifecycle tracking, whatever. So this is what he was asking about specifically. Projects are like a particular format, and then models. So everybody's going to have their own favorite format for versioning metadata. Everybody's going to have their own like YAML or JSON. Everybody's going to have their own opinion on how that works. You're going to need to, like I said, you're going to need to deal with this no matter what framework you're dealing with. So Seldon, TensorFlow Serving, MLflow, there's all sorts of like open source platforms that do this. Okay. Okay, now, all right, let's go ahead and, let's go ahead and take another break, like 10 minutes, and then I'll help anyone who's left over from troubleshooting, happy to help. Okay?